Hi, have you wondered how a football pitch with length 90 meters to 120 meters can be represented on a paper using just less than 15 cm? Or how Nigeria, with a large landscape of over 900,000 square kilometers, can be represented on a paper with just few cm? This is only made possible using scale factor, area factor, and volume factors. In this video, you will learn how to solve problems under area factors, volume factors, and even using scale factors to reduce and to enlarge some images. Now consider these packets of Omo. Are they similar? What about the images of the map of Nigeria? Here are two triangles. Are they similar? If you said yes, why? Did I hear you say they are the same shapes? You're right if that was your thought. These figures are similar. Similar figures are figures with the same shapes but can be with different sizes. Now, let's take a look at similar triangles. So, how do you identify similar triangles? To identify similar triangles, note that the corresponding angles must be equal. Likewise, the corresponding sides must be in the same ratio. Now, take a look at these similar triangles. You will notice that angle A is corresponding to angle P. Hence, angle A is equal to angle P. Similarly, angle B is corresponding to angle Q. Hence, angle B is equal to angle Q. Angle C is also corresponding to angle R. So, angle C will be equal to angle R. Also notice that side AB in triangle ABC is corresponding to PQ in triangle PQR. Also, BC is corresponding to QR and CA is corresponding to RP. If the length of their sides are as follows, then AB all over PQ will be equal to 6 all over 3, which is equal to 2. BC all over QR will be equal to 4 all over 2, which is equal to 2. And CA all over RP will be equal to 2 all over 1, which is equal to 2. Did you notice something? Yes, the ratio of their corresponding sides are equal. Now take a look at the similar triangles. Write down the sides in triangle ABC which corresponds to sides PQ, QR, and RP in triangle PQR. Now angle P corresponds to angle A and angle Q corresponds to angle B. Hence, PQ corresponds to AB. Similarly, angle Q corresponds to angle B and angle R corresponds to angle C. Therefore, side QR corresponds to side BC. Similarly, angle R corresponds to angle C and angle P corresponds to angle A. Hence, side RP will correspond to side CA. Okay, having understood similar triangles, Let's take a look at scale factor. When images are enlarged or reduced, it is done using scale factor. Scale factor is the ratio of the length of the corresponding sides of two similar geometric figures. Now take a look at these similar rectangles. You would have noticed that side BC corresponds to side RX and side QR corresponds to AB. Hence, the scale factor is equal to RX all over BC, which is equal to 6 all over 4. 2 into 6 and into 4 will give you 3 all over 2. Or you could use side QR all over AB, which is equal to 3 all over 2. Here again, we have established that the ratio of the corresponding sides of similar figures are equal. This is so for all similar figures. Here is an example on scale factor. In the figure below, rectangle OXYZ is enlarged to rectangle OXYZ prime, where O is the center of enlargement. A, if OX is equal to 2 cm and XX prime is equal to 1 cm, find the scale factor of the enlargement. And B, hence find OZ prime given that OZ is equal to 5 cm. Here is the solution. Remember that scale factor is the ratio of the corresponding sides. In the given problem, OX is corresponding to OX prime, hence the scale factor is equal to the length of OX prime all over OX. The length of OX prime is 2 plus 1, which is equal to 3, and the length of OX is 2. Therefore, the scale factor is 3 all over 2. In the part B of the given question, you are asked to find OZ prime, given that OZ is equal to 5 cm. Remember that the ratio of the corresponding sides of similar figures are equal. Therefore, OX prime all over OX will be equal to OZ prime all over OZ. OX prime is equal to 3 and OX is equal to 2 and OZ is equal to 5 cm. Therefore, 3 all over 2 will be equal to OZ prime all over 5. When you cross multiply, you would have 2 times OZ prime is equal to 3 times 5. To get OZ prime, you divide both sides by 2. Therefore, OZ prime will be equal to 15 all over 2, which is 7.5 cm. Here is another example. In the figure below, PQ prime is an enlargement of PQ with center O. A, if OP is equal to 2 cm and OP prime is equal to 5 cm, find the scale factor of the enlargement. B, if PQ is equal to 3 cm, calculate PQ prime. Here is the solution. Don't forget that scale factor is the ratio of the corresponding sides. Here, the scale factor will be equal to OP prime all over OP. OP prime as given is 5 and OP is equal to 2. Therefore, OP prime all over OP will be equal to 5 all over 2. 5 divided by 2 is 2.5, which is the same thing as 2.5 cm. For the part B, remember that the ratio of the corresponding sides are equal. So, OP prime all over OP will be equal to PQ prime all over PQ. OP prime, as seen earlier, is 5 and OP is equal to 2. Therefore, 5 all over 2 will be equal to PQ prime. PQ is equal to 3. Hence, 5 all over 2 will be equal to PQ prime all over 3. To get PQ, you cross multiply and you'll have 2 times PQ prime equal to 3 times 5. 3 times 5 is 15. If we divide both sides by 2, PQ prime will be equal to 15 all over 2. 15 divided by 2 is 7.5 cm. Alright, I hope you understood scale factors. Now let's take some examples on volume factors and area factors. Now consider these similar rectangles with the length of 7 cm by 3 cm and 28 cm by 12 cm. The area factor is the square of the scale factor, while the volume factor is the cube of the scale factor. Remember that the scale factor is the ratio of the corresponding sides, which is 28 cm all over 7 in this case, or 12 cm all over 3 cm. 7 can divide 28 to give you 4, and 12 can be divided by 3 to give you 4. So the answer is 4 cm in both cases. Hence, the area factor will be equal to 4 squared, which is equal to 16 cm squared, and the volume factor will be equal to 4 cube, which is equal to 64 cm cube. Here is an example on scale factor. In the figure below, AC is equal to 16 cm and PRO is equal to 10 cm. Calculate the area of triangle ABC and triangle PQR. Now, here is the solution. Remember that the area factor is the square of the scale factor, and the scale factor is the length of the corresponding sides. In this case, it is the length of AC all over the length of PRO. From the question, the length of AC is 16 cm and the length of PRO is 10 cm. Therefore, scale factor will be equal to 16 all over 10. 2 into 16 is 8 and 2 into 10 is 5. Therefore, the scale factor will be equal to 8 all over 5. Hence, the area factor, which is the square of the scale factor, will be equal to 8 all over 5 all squared. But note that area factor is the area of triangle ABC all over the area of triangle PQR. So, the area of triangle ABC all over the area of triangle PQR will be equal to 8 all over 5 all squared. 8 squared is 64 and 5 squared is 25. This means that the area of triangle ABC is equal to 64 cm squared and the area of triangle PQR is equal to 25 cm squared. This is the required answer. Here is another example. The ratio of the areas of two rectangular feet is 25 all over 9 meters. A. Find the ratio of their lengths, and B. The smaller feet is 120 meters long. Find the corresponding length of the larger feet. Here is the solution. If these are the rectangular feet and the ratios of their area is 25 all over 9, this means that the area of the larger feet is 25 cm and that of the smaller feet is 9 cm. Hence, the area of the larger feet all over the area of the smaller feet is equal to 25 all over 9. To get the length of the smaller feet and the length of the larger feet, we take the square root of 25 all over 9. Therefore, the length of the larger feet all over the length of the smaller feet will be equal to the square root of 25 all over 9. The square root of 25 is 5 and the square root of 9 is 3. This means that the length of the larger feed is equal to 5 and the length of the smaller feed is equal to 3. This is the ratio of the length of the feed as required in part A. In part B, we are asked to find the corresponding length of the larger feed when the length of the smaller feed is 120 meters long. To do this, you substitute the length of the smaller feed into this equation. Hence, the length of the larger feed all over 120 meters will be equal to 5 all over 3. When you cross multiply, 120 will multiply 5, and 120 times 5 divided by 3 is 200 meters. The length of the larger feed. Now let's take an example on volume factor. Two pots similar in shape are respectively 21 cm and 14 cm high. The smaller pot holds 1.2 liters. Find the capacity of the larger one. Here is the solution. If these are the pots with height 21 cm and 14 cm, then the volume factor is equal to the cube of the scale factor. Remember that scale factor is the ratio of the corresponding sides. In this case, it will be the height of the bigger pot all over the height of the smaller pot. The height of the bigger pot is 21 and the height of the smaller pot is 14. So the scale factor will be equal to 21 all over 14. 7 can go into 21 to give you 3, and 7 into 14 it's 2. So the volume factor will be 3 all over 2 or cube. 3 cube is 27 and 2 cube is 8. This means that the volume of the larger pot all over the volume of the smaller pot will be equal to 27 all over 8. Remember that we are asked to find the volume of the larger pot if the volume of the smaller pot is 1.2 liters. So if we substitute into this equation, we would have the volume of the larger pot all over 1.2 equal to 27 all over 8. Now if you cross multiply, you'd have the volume of the larger pot will be equal to 1.2 times 27 all over 8. If we convert 1.2 to fraction, you'll have the volume of the larger pot equal to 12 all over 10 times 27 all over 8. Now 4 can go into 12 to give you 3, and 4 into 8 will give you 2. Hence you'd have 3 all over 10 times 27 all over 2. 3 times 27 is 81, and 10 times 2 is 20. Therefore, the volume of the larger pot is 81 all over 20. 81 divided by 20 is 4.05. Therefore, the capacity of the larger pot will be equal to 4.05 liters. This is the required answer. Okay, I believe you followed through the examples on area factors and volume factors. Alright, you have learned what scale factors are, and you have also learned how to solve problems under area factors and volume factors. Until next time, bye-bye.